Hey guys, I'm Pat Kelly. And what they want us to do in this problem is to find the sum using the formulas for the sums of powers of integers, is what it says. That's a mouthful, but the good news is that it comes down to formulas. So it's always nice if it's kind of like plug and chug. But let's get there. To begin a problem like this, what you want to do is take your sigma notation expression and try to break it down. Try to spread it out if you can. The way that I do that is any kind of addition or subtraction on the inside, you can separate and then give each term its own sigma sign. Okay? For instance, on this one, this equals n squared and the n are separated by subtraction, so I will give each one the sigma sign and separate them like this, making two different sigma notation expressions, okay? And then each one of them does get the same indices here. N equals 1 up to 6, so n equals 1 up to 6, and n equals 1 up to 6. Okay, now, if there were any kind of constant factors attached to any of the terms, any kind of coefficient, you'd also want to take this, in this step, take the time to break it down further and pull the coefficient out in front. I don't have any coefficient other than ones, but imagine, if you will, if there were a 7 right there, then I would take that 7 and bring it out in front of the sigma notation, okay? Do that everywhere that you can, and then you're ready to go. You're ready to go in the sense that now you should start to be matching those formulas that they mentioned. The formulas for the sum of powers of integers, okay? So this part here, I'm intentionally going to ignore the 6 for a second. I'm going to put it on the back burner, if you will. But this part here is the formula that you should know. You should know what n squared, when you add it up, ends up equaling. So let me go down into my next step and try to implement that formula. When it's n squared, it always ends up being m times m plus 1 times 2m plus 1, all divided by 6. And I will give you a quick heads up. Your book, your notes may have an n right there. I switched it to m just because I don't want to confuse it with this n that's up there, okay? All right, let me keep going. This subtraction carries down to here, and this is actually another one of those formulas that you should know. Again, I'm going to ignore the 6 or put it on the back burner for a second. This formula, when you add up just integers to the power of 1, ends up being m times m plus 1 over 2. That's very much what they're referring to in terms of the formulas that we're supposed to use. Okay? Now, one more thing here is this 6 that I've been ignoring that does still come into play. Let me write it over here. For us, m, that dummy variable that I've been using, is the 6. Okay? That's it. That's it, which just means now I'm going to come down to my next step and put that value of 6 in everywhere that I see an m. Okay? So 6 times 6 plus 1 is 7. Let's just do a little bit of arithmetic in our heads. 2 times 6 is 12, plus 1 is 13. I still need to divide all of that by 6. Subtract 6 times 7 divided by 2. Maybe one more step here. Maybe, well, I do it in one line, I think. Some arithmetic. 6 is divide out. 7 times 13 is 91. Subtract. 2 goes into the 6. Leaves me with a 3 times 7 is 21. And I'll do that arithmetic as well. 70? Sound good? That's all we're looking to do. Okay? Try some more on your own. I know you'll do well.